Hello, Professor Mike. This is Cassandra Fuster with my renal and nephron video. First, I would like to start with the renal system. So we've got the kidney, which there are two kidneys in the body, and it is what filters your blood to create urine. And so the blood comes in from your renal artery into the kidneys here, and in the kidney you have two major areas. One is the cortex, which is the outer area, and the next is the medulla, and that is your inner area here with these renal pyramids as well as the renal pelvis. And the renal pyramids, they are what have nephrons, and the nephron is what takes your blood and filters it to make urine. And that goes out of the renal pyramid in the tip, out into your renal pelvis, and then that comes out of your ureter down into your bladder. So, now that we've covered this somewhat, we can go on to the nephron in actuality. So this is a little model I made. Not the best, but I feel like it works. So, the nephron, let me get, here, I think this will help. The nephron here, if you can see it here, it's got the renal pyramids, which are the pyramid-shaped pieces in the kidney, and it has this little loop that goes down into the base of the renal pyramid, down into it, and it kind of rests like that. This drawing is very big, so that's not how big it is in actuality, but that's kind of how it's set up. And there are hundreds to thousands of them. And now this is a little model. And so we'll go over the different parts of the nephron and how it works. So first off, and we've got a cat. So first off, we have the blood supply, because the nephron filters the filtrate of the blood to get rid of all the waste from all the metabolic processes throughout the body. And so we have two veins, one, the top one here, that goes into the nephron, that feeds it, and that's called the afferent with an A, and that brings blood down into the glomerulus, which is this kind of ball of the capillary, which is just like compressed really tight to squeeze out the filtrate of the blood, kind of the plasma with the waste, and that comes out into this capsule, which is called the Bowman's capsule, and that's what I have for this bottle cap here. And that, once it gets filled, the filtrate comes up and it enters this first spot, which is the proximal, proximal convoluted tubule. That's what it is. All right. But the next of the capillaries, so we had the afferent, which is the feeding one, and then we have the afferent, which comes out the other side and wraps around the proximal convoluted tubule, and it carries on, and it's all wrapped around, and it feeds the whole system. Now, because the blood coming in is very high pressure, because it's an artery, it gets squished, and that squeezes out the filtrate and the waste. That waste comes up into the proximal convoluted tubule. the proximal convoluted tubule isn't straight like this straw here. It's like squiggly, kind of like a worm doing a squiggle. And it is where your first spot in where you can take out and bring back into your body all the stuff that you didn't want to get rid of from your blood. So stuff that got taken out that isn't waste, you want to bring that back in, and that is the first spot where you can do that. And it usually does that. Let me flip the page here. And stuff that it takes in and takes back are usually stuff like salt and water and that kind of stuff. So the good stuff, the vitamins that you want to keep in your blood and keep in your body. And so that you take out of the proximal convoluted tubule, you would put back into the blood, which is your efferent tube or efferent artery here. And after the proximal convoluted tubule, we go on to the loop of Henle, which descends into these renal pyramids. So I've kind of got the cut off bottle to act like a renal pyramid somewhat. And so in the renal pyramid, we have osmolality, which means from the top, as you get deeper, it gets more and more salty. So starting off, you could think of it like you have a salt content of 1, and then 2, and then 3, and then all the way down, you could have a salt content of, say, 6. Now, what it does in the loop of Henle is to try to retain water and retains good stuff like that you want to keep in your body, but mainly it's for water conservation, so to keep the water in. And the way it does that is because it's a tube, it has to happen by osmosis with a semi-water permeable barrier. And the only way for that to happen is if there's diffusion, and that happens because one area is salty and one area is not. So inside the tube, it's very not salty. And so what we want to do is we want to make it salty. So we take the salt from down or from inside the renal pyramid and we introduce it to that filtrate that's coming down. And so the first spot, it gets to the first layer of salt in the renal pyramid, and that's a 1. But inside this, the loop of Henle, it doesn't have any, so it needs, that salt needs to, the water will leave the salt, or will leave the tubule, follow the salt, because water follows salt, so the water will leave the tube and follow the salt out into the renal pyramid, into this bottle. And so then it can continue, and the water keeps leaving, and that's to concentrate the filtrate. So it takes the water out of the filtrate, which is in the loop of Henle, and puts it into the renal pyramid. And that is what concentrates your urine and makes that the very concentrated, foul-smelling urine. And so you continue down, and water keeps leaving until you get down to the bottom. And then that's your descending loop of Henle. And then you get to the bottom and you start going back up. And that's your ascending loop of Henle. And the ascending loop of Henle wants to get rid of now the salt that's in the filtrate, that's at the bottom of the loop of Henle. And so now you have a lot of water in the renal pyramid from your descending. So now there's more water in the renal pyramid than there was before, and that causes the difference in osmosis, so osmolarity. So the salt now that's in the tube, in the loop of Henle, it now starts going out into the renal pyramid, and it goes up. So from 6, you would have a concentration of 6. Well, now the salt's leaving, so now it's going up to 5, and then it leaves again, and it goes up to 4, and then it does that all the way up back to the top. And then we get to the distal convoluted tubule. And in the distal convoluted tubule, we can take more water and put it back into the vein to retain that water. And from the distal convoluted tubule, it connects to a connecting drain. And the connecting drains go down and down, and they have hundreds of these nephrons connected to them. And so it drains tons and tons of concentrated urine. And what comes out from the blood, two of the main things is creatinine and urea. Urea comes from the liver and is the process of the liver filtering through all of your food and blood and all that stuff. And creatinine is from the waste of muscle metabolysis. So you have to feed your muscles a lot, and creatinine is produced from that feeding, and you want to get that out of your blood. So now, using this process, we get that to the connecting tubule, and from the connecting tubule, it goes out into the pyramid, and they have these little papillae, which are like these little tips on them, and that leaks the urine into the renal pelvis, which is kind of like the bladder of the kidney, you could think. And from there, it goes out of the ureter down into what is your bladder, and then from your bladder, you urinate. And that is my video. All right, so we have the 4 hormones for this process, the nephron. 4 of the really important hormones, and 3 of them happen in the distal convoluted tubule. The first one is the antidiuretic hormone, which is used for water retention. So it increases water permeability, so it increases the ability of the DCT, or the distal convoluted tubule, to release water back into the vein here. And that helps to increase blood pressure and keep your water in your body instead of leaving it all. And the next one we have is aldosterone, and that is used for sodium and potassium balancing in the blood. And that can help to increase the blood and pressure and volume. And the third one is the parathyroid hormone, and that increases the calcium reabsorption, because calcium you want to keep in your body because it's a very important vitamin for our bones and our blood and the rest of our body as well. And so that we do in the DCT as well. And then we have the atrial natriuretic peptide hormone, and that one we use for water secretion, and that's to lower blood pressure. Now, having low blood pressure is something that's very dangerous. So we actually don't have very many hormones in our body to lower our blood pressure, because we can go years with high blood pressure, but if we have low blood pressure for a short amount of time, we can die. So it's very important to have the hormones that increase blood pressure. And so this is one of the few that actually decreases blood pressure, and that's the atrial natriuretic peptide. There we go.